Solve problem 1 convolution sum. In this problem, I had taken the two infinite duration sequence u of n and u of n. They are the infinite durations, right-sided infinite duration signals. Question here it is: consider an input x of n and an unit impulse response h of n. That is given by x of n is equal to alpha to the power of n into u of n, where alpha is in between the 0 and 1. You can take alpha is equal to 1 by 2. And h of n is equal to u of n. You should evaluate this and output signal should be plotted. Okay, solution to this here is, we know that impulse, that is output of any LTI system, is given by x of n is y of n is equal to x of n, that is linearly convolved with h of n. That is y of n is equal to summation of k tends from minus infinity to plus infinity x of k into h of n minus k. See here, both are infinite duration sequence. We need to fix up the summation range here. What is x of n here? X of n is alpha to the power of n into u of n, where alpha is in between 0 and 1. Suppose if I take that alpha is equal to 1 by 2, it will become, that is, when n is 0 it will be 1, when n is 1 it will be 1 by 2, when n is 2 it will be 1 by 4, when n is 3 it will be 1 by 2 to the power of 3 is 1 by 8. It will become a decaying exponential signal. That is multiplied by u of n. U of n exists only from 0 to infinity. That is, when you draw this input signal, x of n, this is the n, this is 0, this is the x of alpha to the power of n from 0 to infinity. It looks 0, 1, 2, 3, 4. It looks like this. This is a decaying exponential signal. When n is 0, its value is 1. It will be less than 1. Again, it will be less than this previous value. It will be less than this previous value. It looks like a decaying exponential signal. Okay. What is h of n? H of n is equal to u of n. It exists, 0 to, from 0 to infinity, because u of n value is 1 when n is greater than or equal to 0 and 0 when n is less than 0. Okay, this is the n, this is the h of n. H of n is equal to u of n. Okay, now x of k is there. Just to replace n by k, it will become x of k. That is, x of k is equal to alpha to the power of k into u of k. Okay, that is, this is h of n. Then y of n is equal to, you can write, that is summation of k tends from minus infinity to plus infinity. This is x of k is alpha to the power of k into u of k, and this is h of n into h of n minus k. H of n minus k is nothing but h of n is equal to u of n. This is u of n minus k. H of n is u of n. Replace n by n minus k, you will get h of n minus k. H of n minus k is equal to u of n minus k. Now here, based on u of k and u of n minus k, we should fix up the summation range here. What is u of k definition? We know that u of k is equal to 1 when k is greater than or equal to 0 and 0 when k is less than 0. That means, what is that? Multiplications of these two should yield a non-zero value. That k must be greater than or equal to 0. Meaning of this is k should not be less than 0. That means you can fix up the lower limit of this from this first signal. When you have two infinite duration sequence, from the first signal you can fix up the lower limit of the summation, because u of k is equal to 1 when k is greater than or equal to 0. Other meaning of this is k should not be less than 0, because when k is less than 0, answer will become 0. When 0 means whole product will become 0 here. Okay. Next you have, that is, u of n minus k equals to 1 when n minus k is greater than or equal to 0. That is nothing but n minus n is greater than or equal to k. It is nothing but k is less than or equal to n. K is less than or equal. That means k should be less than or equal to n. What is the other meaning of this? K should not be greater than n. That means that gives the upper limit of this. Finally, I can conclude that y of n is equal to summation of k times from lower limit is 0, upper limit is n. This is alpha to the power of k into u of k value is 1 and u of n minus k. There is nothing but h of n minus k. Okay. Now, this is a fixed signal. U of first one is always fixed signal. Second one is the moving signal. Based on the value of k, it moves. When k is 0, it will be u of n. When k is 1, it will be u of n minus 1. There is nothing but h of n minus 1. Okay, based on this signal, based on this movement of this signal, we should check where we get the non-zero value. Okay, now that is, we have y of n is equal to summation of k tends from 0 to n alpha to the power of k into u of k into u of n minus k. This is nothing but h of n minus k, where h of n is exist at 0 to infinity. H of n minus k is what depends upon value of k. We have to check. We have to take three cases here. When n is 0, what happens? When n is 1, what happens here? Okay. This is u of n minus k. When n is 0, we will take three cases when n is equal to 0. When n is equal to 0, this part will become, that is u of minus k. What is u of minus k? When n is 0, this first signal exists because u of 0 value is 1. Alpha to the power of 0 value is 1. Sorry, u of k will change, it will remain as it is. It is a decaying, that is from 0 to infinity. U of n minus k, when n is 0, you will get u of minus k. What is u of minus k? U of k value is 1. This is the u of k. Okay, 0, 1, 2, 3, it goes like this. This is the u of k. Because definition of u of k, what it says, u of k is equal to 1 when k is greater than or equal to 0. What is u of minus k? It's reflected signal. This is the u of minus k. 0, minus 1, minus 2. This is the u of minus k. See, first signal exists is fixed signal. It exists from 0 to plus infinity. This is a decay exponential signal. When n is 0, second signal is u of minus k that exists from 0 to minus infinity. Multiplications of these two are possible only at 0. Only at 0. Hence, output y of n gives a non-zero value. Output y of n is not equal to 0. That means when n is 0, output is not equal to 0. You have some value here. This is the first case. Second case, I should take that when n is less than 0. That means I'll take n is equal to minus 1. Then in that case, what happens? U of minus 1 minus k. How do you write u of minus 1 minus k? That is nothing but that is, you can write this one as u of minus k minus 1. First shift the signal u of k to the right hand side by 1 unit and then you take a reflection. This is the u of k. When you shift it to the right hand side by 1 unit, that u of k minus 1, it comes at 1, 2, 3, it goes till plus infinity. This is the u of k minus 1. When you take its reflection because of this minus k, this signal comes here. This is minus 1, this is minus 2, this is minus 1, this is minus 2, this is minus 3, this is 1. This is the u of minus k minus 1. Okay, see, this signal starts from minus 1, ends at minus infinity. Whereas first signal is there from 0 to plus infinity. Multiplications of these two is not possible. Multiplication is possible only when two signals overlaps. Okay, hence you can say that output is equal to 0. That means you can conclude that when n is less than 0, output y of n is equal to 0. Next, third case. When n is greater than 0. You take n is equal to 1. If you take n is equal to 1, what happens? That is u of 1 minus k. That's nothing but u of minus k plus 1. Let me shift the signal to the left hand side to 1 in it. This u of k signal. It starts from minus 1. This is the u of k plus 1. Because of minus sign, you take its reflection 1 to 0, 1, minus 1, minus 2. It goes like this. This is the u of minus k plus 1. See here, u of minus k plus 1 signal exists from 1 to minus infinity after doing shifting and reflection. Whereas x of an input signal exists from 0 to plus. This is a fixed signal. It exists from 0 to 1. See, when input is always fixed signal, only thing is impulse response is a moving signal here. Okay. To have a non-zero value, your moving signal, that is movement of this signal, is based on the eigenvalue of n. This should overlap with this, then only the multiplication is possible. Now, this exists from 0 to infinity, where this exists from 1 to minus infinity. That means multiplication is possible at 0 and 1. Suppose if I take n is equal to 2. Suppose if I take n is equal to 2, what happens? You will get u of 2 minus k. U of 2 minus k means this is u of minus k plus 2. It exists from 2 to minus infinity. 2 to minus infinity. Okay. Then multiplication is possible. First signal does not exist less than 0. That's why multiplication is possible only from 0 to 2. See here, when n was 1, multiplication is possible up to 1. From 0, when n was 2, multiplication is possible up to 2. From 0, that means when n was 1, multiplication is possible at 0 and 1. And n was 2, multiplication is possible at 0, 1 and 2. That means till the value of n, I'll get the answer here. That means finally I can write that here is y of n is equal to summation of k tends from 0 to n alpha to the power of k. U of k value is 1 and u of n minus k value is also 1. That is, we know the series, that is summation of k tends from 0 to n a to the power of k, that is equal to 1 minus a to the power of n plus 1 divided by 1 minus e. That is, modulus of a is less than 1. Using this series, I can write that y of n is equal to that is 1 minus alpha to the power of n plus 1 whole divided by 1 minus alpha. Okay, since it exists only at the right hand side, multiply by u of n. Okay, this answer holds good only when n is greater than or equal to 0, because when n was less than 0, answer was 0. Finally, I can write that this answer holds good when n is greater than or equal to 0 and its value is 0 when n is less than 0. Okay. Now, how to plot this here? That is, when take any value of alpha here. Suppose if we take alpha is equal to 1 by 2, it will become 1 minus 1 by 2's denominator, it will become 1 by 2. That goes to numerator, it will become 2. 1 minus of 1 by 2 whole to the power of n plus 1. It will always, this value is smaller. 1 minus of that, you get some number that is multiplied by value 2 when it is alpha is 1 by 2. That means when n is 0, 1 minus alpha whole divided by 1 minus alpha, I will get answer, it will become 1. When n is 1, it will be more than 1. When n is 2, it will be more best value. When n is 3, it goes like this. Okay, it reaches the, what is the maximum value? When n is infinity, that is when n goes to infinity, it will become alpha to the power of 1 by 2, because alpha is in between 0 and 1. Alpha to the power of infinity is, it will become 0, because 1 alpha, if I take 1 by 2, 1 by 2 whole to the power of infinity is, denominator is more, numerator is 1, always that will become 0. 1 divided by 1 minus alpha you will get. This is an infinity. Okay, this is the output. This completes the problem.